Good day, everyone. Let's solve this exponential equation. Squaring both sides, it means we have 3 root x is equal to 2 to the power of x. So square both sides. Square of 3, that's 9. Square to the square root, they cancel each other. So we have 9x is equal to squaring this under law of indices. If you remember, this and this will multiply. Recall, you have a raised to power n into n. So it means a raised to power n times n. So applying that here. So x times 2. So that will be 2x. So raised to power of 2x. Introducing exponential. Let's recall. You have exponential of natural log of x. That will give us x. Because exponential and natural log cancels out the reciprocals. So let's introduce that here. Introducing that here, it means we have 9x is equal to exponential ln 2 raised to power of 2x. So it means this, we have introduced exponential and the natural log. So the next thing we have to do here, we also have to recall that when you have ln a raised to power of x, under the law of logarithm, this power can slot in a. So it means we now have ln, we have x ln a. So let's introduce that, let's use it here. So it means when you have ln 2 raised to power of 2x, it means this 2x can come over here. So we have 2x ln 2. Putting that here, we have 9x is equal to exponential, instead of having this, it will now be 2x ln x. The next thing we have to do is to collect the like terms, so that anything that deals with x will be at the same side. So we divide both sides by exponential of 2x ln x. So it means we have 9x, let's write that, is equal to exponential of 2x ln x. So divide both sides by exponential 2x ln 2 divided by exponential 2x ln 2. This cancels this. So we are left with 9x times 1 over exponential 2x ln 2 is equal to 1. So this gives us 1. Now, this is the same thing as this. 1 over a raised to the power of x. It means a raised to the power of minus x. So we apply that here. So what do we have? We have 9x exponential of raised to the power minus 2x ln 2 is equal to 1. Now, there is a method we can use to solve this, which is called Lambert W function. Before we can do that, it must be of the form x exponential x. That's an example. That a function exponential this. So finding the Lambert W function of this, it will give us just what is here. If it is like this, any function, okay, the Lambert W function will give us that. So let's write this in that form. Multiplying both sides by minus 2 ln 2, it means we have minus 2 ln 2 into 9x exponential minus 2x ln 2 is equal to 1 times minus 2 ln 2. So we have done that to both sides. So we have to divide both sides by 9, because this 9 is odd. So it means we divide this by 9. We also divide this by 9. It means here 9 cancels 9. So we are left with minus 2 ln 2 x exponential of minus 2x ln 2 is equal to minus 2 over 9 ln 2. So now we have minus 2 ln 2 And here we have minus 2x ln 2. Now there is an x here. So this x comes here. So we have minus 2x ln 2 exponential minus 2x ln 2 is equal to minus 2 over 9 ln 2. Now, if you remember what I said here, when you have something here, exponential, another thing, finding the lambda w function will give you that thing. So we have to introduce that here. So we can introduce our w function. To introduce our w function, we introduce it to both sides. So what do we do? So we have lambda w function here. We also have lambda w function. So this sorts this out. So we are left with only minus 2x ln 2 is equal to lambda w function of minus 2 over 9 ln 2. So from there, we want x to stand alone. So we have to divide both sides by minus 2 ln 2. So dividing both sides by minus 2 ln 2, divide this also by minus 2 ln 2. So this cancels this, and this cancels this. So we are left with x equals to this minus, we have to come to the denominator, minus w function of minus 2 over 9 ln 2, all divided by 2 ln 2. So we can insert this into our calculator if you want to get the figure. But this is our final answer. That's the value for x. Thank you for watching this video. If you are new to this channel, please subscribe, like our video, press the bell icon. Thank you. See you in another video.